This video is brought to you by Sporlan. Quality, integrity, and tradition. Okay, I want to start this video off by giving you guys a disclaimer. I'm working on an R-290 hydrocarbon refrigerant system, okay? It can be dangerous. It's nothing to be afraid of, but you do have to follow some safety procedures, okay? I would highly suggest that you guys consider looking up rses.org, and they have a R-290 or a hydrocarbon refrigerant training program that you can take. And then also True Manufacturing, Delfield Manufacturing, and then I'm sure there's a couple other manufacturers also have YouTube videos that show you the proper procedures to follow when working on hydrocarbon systems, okay? Do not try this if you are not a professional and are not trained with systems like this. Again, it's nothing to be scared of, but there is some risk in as long as you follow the proper refrigeration practices that are laid out in those training programs I told you about, then you should be fine. Always wear your safety gear, always have fire extinguishers and all that good stuff, okay? Also, there's going to be lots of tools that I show and mention in the video. There'll be links in the show notes of the video, okay? All right, so here we go. Okay, we've got a Delfield cooler that's not working right. Temps are high, both top and bottom. Compressor's not running. It says that the compressor's running on the temperature controller though. Both the snowflakes are on, and it says that the fan's running on the bottom section. And the fan is running, but we are not temping properly, for sure. The compressor every once in a while will turn on. So the first thing we're gonna check is that the temperature controllers are sending power and that the low pressure control is either open or closed. So we'll get in here, find the low pressure control, and check the circuit. Upon opening this, look at this. They're not supposed to use regular wire nuts. Delfield doesn't. So this almost makes me think someone has changed this low pressure control before. So we have an open low pressure control. So our next step is to put service gauges on the unit because both the top and the bottom are temping high. This is an R-290 system too, by the way. So it looks like, see, it just closed. And let's see how long it closes for. And then it just opened. So it's short cycling essentially. So it looks like we might be either low on charge or a faulty low pressure control. Before I go any further, I'm going to go ahead and do a quick leak check. So I powered the unit down and we're going to wait for my leak detector to zero out. This is a combustible gas leak detector made by Infocon. It's called the GasMate. Once that zeroes out, then we'll do a quick leak check on the evaporator and the condenser, see if we have any obvious leaks. Then after that, we'll proceed to put service ports and check the charge if need be. All right, we're zeroed out, so we'll do a quick one on the condensing unit, see if we pick anything up. I'm not gonna go crazy, just quick check, seeing if we have any obvious leaks. Nothing yet. Drier down there. Service ends. Nothing yet. The back in here. Nothing back in there yet. The evaporator's the obvious place. Jump in here real quick. Interesting. Usually we would have found it by now. So there's definitely some corrosion happening because of the acidic products they store in here, but I'm still not picking up any leaks. So we're gonna go have to put service taps on this guy and check the refrigerant charge while it's running. All right, so we're gonna have to add service ports. We're gonna use the existing process stubs that they gave us. I'm sanding them up right there.
got all my safety gear, got a fire extinguisher handy, and we're gonna get ready to do this because the theory is that there's still refrigerant inside this unit. And remember, this is a flammable, unodorized R-290 refrigerant. Take off the rubber gloves so that way they don't melt on my hands. Okay, so we're gonna start by pinching off the line down low. Nice and good. Then we'll cut it. The wheel on my cutter is getting worn out. I need to put a new wheel on this thing. We have to do them one at a time. There we go. We had a little bit of spray off. Slide the fitting on. Looks like my tip's a little dirty, but it'll do for now. Remember, being very safe. So I ran the torch across the outlet of the fitting just to make sure it wasn't leaking through this, and it's not, because it would ignite if it was. Remember, very safe because this is flammable propane. Always have your safety gear near you. Remember, be prepared for the worst. That way, when and if it does happen, you don't panic. Cool. Now we're going to inspect that. And if it checks out, then we'll go ahead and put the Schrader in it. And using my inspection mirror, looks like a clean fitting. Normally I would say let it naturally cool, but I want to do this quick. It's always best to let them naturally cool because you can compromise the braze joint. Sometimes when you have sensitive materials, you just got to do what you got to do. Nice and good. So now we're going to go ahead and insert our Schrader. Once we make sure that it's not too hot, I should be able to grab this and hold my hand on it. It's warm, but it's not hot enough to melt the O-rings. I've got a little ratcheting tool that'll tighten the Schrader to the right torque setting. It clicks, just like my elbow when I tighten the flare. So, okay, now we can go ahead and remove this. What you can do is press on the Schrader. There's a little bit of flow, but not much. So the next thing I'm going to do is take my channel locks and go the opposite way of the crimp and just give it a slight pinch, just to open the airway. Oops, there we go. Airway open. Now we got to move on to the next one. Pinch it right about here. Cut it off. Slide the fitting on. Braze it. I definitely need to clean my tip. Run it across the top, make sure it doesn't ignite so we don't have a leak. And then we can go ahead and braze it on real quick. Be mindful of where that's pointing just in case the pinch was to let go. It doesn't blow the flamethrower in your face. More than enough solder, but I'm a little generous with my solder. I just like to be safe. Heat it up. Inspect it real quick. Make sure that it looks like it took. It did. It did. I'm gonna go ahead and cool it. Grab it with my fingers. Then we can go ahead and insert our Schrader. And be careful because now there's a pinch point. This is a weak spot, so you never want to leave these without reinforcing them. But this is just to check pressures. Okay. Give it a poke on the Schrader. Needs a little bit of opening, just like the other one. Try not to go as far as I did on the other one. That's good. Now we can check our pressures. So at this point we have equalized 125, 85 PSI pressure. Everything's safe. We're going to go ahead and turn the main power switch on and watch the system operate. See if we shut off on low pressure. We're watching that low side control. That doesn't look good. So it looks like we're calling for refrigeration, the snowflake. That one's actually defrosting, so we can hold that down. Sorry about the flickering. It's my frame rate on my camera. Okay, so let's watch. Look at 75 PSI and we're shutting off on low pressure. And we can go ahead and get the meter in there just to verify, but here we go, we're turning on. See, and it's going down to 60 PSI and it's shutting off on low pressure. So let me get my meter on there. So I tapped the low pressure control and it shut off. So we're at 65 PSI and we've got an open control. So we've definitely got a bad low pressure control. Tap it and it turns on. So it's just faulty. Also need to verify the settings, but I know that the pressure control should be pulling down. This is a pump down system, so that pressure control's cutout's probably going to be 5 to 10 PSI, my guess. I'll verify, but I'm pretty sure. So we'll get a hold of the factory, get the parts ordered, and then see if we can't get this fixed. So this is very important. There's major liability issues. You cannot top off the charge. You cannot bypass pressure controls or anything when you're working with R-290. If it has a leak, you take it out of service until you get the parts to fix it. You do not top off the charge. If it has a bad pressure control, you do not bypass the pressure control. Everything is a major liability issue, and you only use OEM parts, period, no exceptions. Even as far down to the electrical cord. You put in a factory electrical cord, like for instance if it got ran over or something like that. You do not want the liability of something going wrong with an R-290 system. Consider this thing to have flammable refrigerant, and this could be a very bad situation if you bypass something and there was a fire or something, God forbid. So very, very careful. And we are back. This is about a week later. I was able to get the parts. We had to order them. Interestingly enough, not a lot of people are stocking these parts, at least the warranty people, so they do have to order them often. But we've got a low pressure control and we've got a liquid line filter dryer. You do have to make sure you use the factory OEM parts. I cannot stress that enough. I was able to move this unit outside to a ventilated area, so it makes it a little bit safer, but we still have to follow our proper safety precautions. So we're gonna go ahead and pull the condensing unit out, sand everything up, and I'll show you guys the process of how we're gonna do this. All right, so remember I added these service fittings the last time, and this is EPA approved. This is R-290 refrigerant. We are gonna vent this into the atmosphere. You wanna make sure that you do not have anything flammable around you and still wanna follow proper precautions. The unit is not plugged in. It is completely disconnected. I have the plug right here, so we're safe on that. We're gonna go ahead and vent this refrigerant, and then we're gonna do a nitrogen purge, and then we're going to start brazing in the new fittings. I just want to note that I do have a fire extinguisher handy and ready in case there's a problem. So we're always prepared, safety glasses, you know, follow all the proper practices because nobody wants to get hurt. Okay, so I've got a ball valve hooked up to here. We're still going to vent it in a controlled releases, so we're not going to release too much at one time. Just so, I mean, even though we are outside, we're still going to be careful. Okay, again, this is completely legal because this is R-290 refrigerant, and this is the proper way if you are in a safe, controlled environment where like outside or in a well ventilated space, you're allowed to vent R-290 refrigerant into the atmosphere. So the refrigerant seems to have all vented out. What we're gonna do is go ahead and take out all of our Schraders, and you'll notice that I also put solenoid magnets on both of the liquid line solenoid valves. There's one for the top and one for the bottom. That's so that way we're sure that our entire system is open to atmosphere. And then the next step is we're gonna give this all a nitrogen purge to ensure that we try to get out as much of the flammable refrigerant vapor, again, R-290 refrigerant, out of the system. Now I will tell you that even with the nitrogen purge, it is still going to have flammable vapor in the system from my experience. So you always want to be careful. Always want to be cautious about this, and still just be prepared for the worst. Remember, I've mentioned before, if you're prepared for the worst when it happens, you know how to react and you tend to not panic as much, okay? So you always want to try to think of the worst case scenario, what can happen here, and just be ready for it. All right, so I've got my nitrogen right here, and I'm currently purging through the system. I'm pushing in through the liquid line and coming out the vapor line, or the suction line. This is the process stub. And what I did was I'm using the VN 500 regulator right here, and I'm gonna go ahead and switch it to the braze mode now, which I did. And now it's gonna reduce the pressure and just push like a steady, like 2 to 3 PSI through the system the entire time while I'm working on it. I'm actually going to go ahead and move the nitrogen regulator so that way it's out of the way of the camera angle. That way is a little bit better so we can actually see what's going on here. So the next step is we're going to sand everything up. We're going to sand all of our fittings, our dryer, get everything prepped. And then that way we can go ahead and just quickly unbraze the new or the old pressure control, sweat in the new one, and then we'll fix these process stubs too. I don't like these pinch points as a permanent solution here, so you'll see what I mean when we're done. Cleanliness is your best friend. Sand everything. And say for instance, can I give you an example? Okay, so on this pressure control over here, I'm just going to be unsweating the top joint of this T, but I'm gonna sand the entire T just in case something comes loose while I'm brazing this. That way it's already sanded, and if I have to lay some solder on it, it's already clean. Always be prepared for the worst, like I said. There really isn't too much scariness to R-290. You just got to follow a couple safety procedures. And in all reality, they're really not that much different than standard refrigeration practices. I mean, they tell you to always braze with nitrogen, you know, so what's the really only big difference is to do a nitrogen sweep in the system before you braze. And then, you know, yes, you are brazing. When you're done, you're going to cut off the pinch off, or you're going to cut off these service ports if you're following proper practices. Now, I've heard some people leaving them on. You know, that's your personal choice. The manufacturer wants you to take them off. So, and this is a warranty job, so I'm gonna go ahead and take them off when I'm done. So, but I mean, honestly, don't do anything you're uncomfortable with. So if you're uncomfortable taking off those pinch off, you know, service fittings, then by all means don't do it, because nobody wants you to get hurt. So, you know, yes, the manufacturer wants you to do it, but don't put yourself in a situation where you don't feel comfortable. Let your company know. Don't be the one to make that decision, you know. Tell them, I don't feel comfortable doing that. And if that's the case, they can either choose to leave them on there, or they can choose to send someone else. But there's no harm, because if you don't feel comfortable, you shouldn't do it. Okay, so we're pretty much ready to get our torch out and do what we have to do. I will go ahead and sand up the new dryer. Just sand the ends on it. And these are OEM parts. You got to go back in with the OEM if that's what, you know, especially on R-290 stuff. You got to put OEM parts back in the system. So just because, like, I have a preference of Sporlan products, but in this situation, I have to use the OEM, especially because this is under warranty. But still, with R-290, you do not deviate from OEM. It is a major liability. So you do not want anybody pointing fingers at you. Okay, I'm gonna get some new process stubs ready, because I did pinch the old ones, so I'm gonna have to make some new ones. You do not want to make them any longer than the OEM ones. They need to be the exact length, to be honest with you, because this thing holds 150 grams of refrigerant, which is like 5.29 ounces. So you gotta put that factory charge back in there. You cannot deviate from that. There's a trick, and I wanted to show you guys something. If you score and break off copper versus cut it all the way through, you notice how on 1/4 inch especially, it pinches it down. So I have to ream this, but if you score it and break it off, you don't really have to ream it so much, or you still probably want to hit a deburr on that real quick. But you notice the difference in pipe there? There's a rather sizable difference. Look at that. So the bottom one was scored and broken. The top one was cut all the way with the cutting wheel. So we're gonna get these prepped and ready for the new dryer. So we essentially just wanna go ahead and do a bend on this, just a tight little bend, and then we can cut it down. And it's pretty much gonna be about right there. So we just kinda wanna mimic what was here. There we go, that'll be nice. And then for the other side, we're just gonna put a slight 45 on it. There we go. And then that should mimic that side, and we're ready. So that way, we've got our fittings ready, and we'll go ahead and trim them down so we have the least amount of work once we get this ready. So we'll trim this guy about right here. Again, we're purging with nitrogen this entire time. Couple turns, one more little turn, and then we'll snap it off. There you go. nice and clean. We can sand that up. Good to go. We'll use that for this side, and this one right here will go on this side. So we just got to kind of get down here, figure out how much we need. I'm going to cut it right about there. So this one's going to cut off about a 1/2 inch. It's probably pretty good. Now when they get really short, kind of need to get a set of pliers or linemen's in there to snap it off, because it's kind of hard to get your fingers on that. There we go. And we'll go ahead and ream those too, just for giggles. So there you go. There you go. We'll go ahead and get the tops cut off. So as a trick, what I do is I use the same ends for R-290 units. So when I'm gonna take them off, I'll reuse them. So I just save them, and it saves me money. That way I'm not wasting money on a warranty thing. Actually, that one I went a little too far, but it's okay. Go. Get these guys sanded up and ready. Again, preparation is key, so that way this goes fast. There's no reason for this to take too much time, but at the same time, you are working with a dangerous refrigerant if not, you know, following the proper procedures. So you do not want to rush through something if you don't feel comfortable. But I like to be efficient and have everything ready. I'm actually lucky in that since I'm outside, there's a water hose nearby, so I do have that prepped and ready too, because in all honesty, that'll probably be faster than a fire extinguisher if I need to extinguish a flame. So, but I do have both still handy. So I got a wet towel ready, and I'm gonna take these rubber gloves off because you don't want to braise with these. Got some pliers ready, everything ready to go, and we're just gonna unsweat the fittings, and then we'll go from there. Okay, you're gonna run it across the end that's open to see if you still have vapors and nothing came out. So we're gonna go ahead and unbraze these fittings. Again, we're pushing nitrogen. There might be a flame out, so be prepared. Okay, one fitting off. That fitting might be breaking right now. It doesn't want to come out. What the heck, man? For whatever reason, that did not want to come out. It was like pinched in there or something. Okay? So here's the crappy part. We have no choice but to turn off the nitrogen. So just going to have to deal with it. This is how some of the R-290 stuff goes. You just got to deal with what you got to deal with. So we're going to turn off the nitrogen, so we could still get a little bit of a flame out here. We are still open to atmosphere. Run it across the top, make sure you don't get any flame. Good. Okay. actuality, that didn't even need to come out, to be honest with you. Okay. Again, prepared for a flame out. There we go. Good there. Well, that sucks because there was like a little fitting on there. And I don't think I have that fitting. Well, that's a bummer. But I'll make it work. It's all good. Melted the cord, so I'll have to shorten that. I made a mistake. Stuff happens. You see that? But we can't leave that there. We'll have to fix it. It's not a big deal. Just again, you just got to be prepared for things to happen and be observant. So, but yeah, that kind of stinks about that fitting right there. Just might have to braze it up. I'm not going to have a fitting that small. So there's a little reducing fitting in there. It's a stinker, man. Dang it. I don't know if I can get that out or not. Yeah. I'm not gonna stress about it. I can braze that up. Very good. See if I can make this fit. Ooh yeah, how's about them apples? So I just made that fitting. Sweet. I could have just brazed it shut, but this is easy enough. bit. It fits on there a little bit better. There we go. There we go. That's in. That's in. We'll have to make sure that there's pressure right here. Bend this line this way so that way it's applying pressure. And when I sweat this, it'll push on. The only tricky part is that this might move. So what we will do is ever so slightly put a pinch on this. So in hopes that it doesn't allow this to move. There, so now this top fitting's not going to move. I can do these real quick. And then we'll get this one ready. Nice and tight. Nice and tight. I'm going to use a little Viper wet rag, heat blocking compound. I'm going to put it right up here because I'm going to put nitrogen while I'm brazing these. Okay. And let me go ahead and grab my low pressure control. Unwind all this nonsense. They got a bunch of wires here. Okay. Some solder ready. Nitrogen blowing through there. I'll push that under. Not like that. Okay, nitrogen flowing. Put a little bend on my tip. Okay, we'll go ahead and do this side first. Notice the flame coming out. It's weird how it'll still come out. You want to be prepared for that. Nobody wants to get hurt. Even with nitrogen flowing through there. What's happening is the R-290 flammable refrigerant is boiling out of the compressor oil. You could try to like agitate the compressor, things like that. Okay? What I'm going to do here is kind of prop this up because I can tell it's going to want to move when I'm brazing it in, because the electrical lines are really heavy, so I don't want them to cause a problem. It's kind of like making it bow. For some reason it's not taking too well.
Make sure that looks good.
Yeah, It looks good. It was just, I don't know, it looked a little sketchy for a minute, but we'll do a pressure test on the system too to make sure everything's good. All right. So we're gonna do everything but this top weld. We'll do that one very last. Okay. See, it just pushed in. That's what I wanted it to do. Okay, last weld. Or braze joint, whatever you want to call it. I know for the braze police. So I moved the nitrogen to the other side just to make sure that we're pushing stuff through. Just to make sure. I'm gonna inspect these braze joints. I'm gonna inspect every weld. Looks good. Looks good. Looks good. Good. Best as I can tell, looks good. I don't have a flashlight with me, so we're gonna have to do a nitrogen pressure test. Let's go ahead and get this wet rag stuff off of here. Use the wet rag so that way it wouldn't damage my O-rings, and there's nothing wrong with them, so the wet rag works good. Okay, we're gonna go ahead and wipe down all the braze joints. It's gonna cool them a little bit. Everything looks good. So now we can do a pressure test and a leak check. Okay, so now we're going to do a nitrogen test. On the nameplate it says the design test pressure is 172 psi on the low side, so you cannot go over that. So we're going to go ahead and put some nitro into here right now. We'll do about 150 psi. we do have a leak. So this is why we do a nitrogen test. We have a leak right here. So we're gonna fix that real quick. Probably going to get in trouble for using these old fittings over and over again. That's probably what's going on here. Hit that guy one more time. We'll be purging nitrogen through from the braze function through the low side. Must be like oil contamination in there because it looks like a solid braze joint. Interesting. Okay. Go ahead and purge. I said we'd go to about 150. That's it. That's all we're gonna do. Close off the nitrogen. Gonna spray Big Blue on everything. And look for leaks. Doesn't seem like any leaks, but we're gonna let it sit for a little while just to see if any microclusters pop up. All right, so we've actually increased in pressure because my outdoor ambient has risen, bringing the box temp up, increasing the pressure of the nitrogen, which is just another point to prove that nitrogen is not an inert gas. It does change pressure with temperature. It's just very slight, but we did increase in pressure. But we've been for 12 minutes and we've held pressure. I'm good. I've done another double check on all the joints and everything's good. So we're gonna call this good and go ahead and get our vacuum rig set up. We're gonna do a single hose setup where I vacuum down. Go ahead and open up gas ballast, plug my machine in. And while it's vacuuming, I'll figure out all the electrical. So remember the solenoid valves, and I'm pulling with the natural flow of refrigerant, so I'm pulling through the suction side. It's not necessary to do that, but I just figure if I'm gonna do a one hose setup, I'm just gonna pull with the natural flow of refrigerant, so. Okay, so we started pulling microns, so we're pulling from one end of the system all the way to the other end of the system. Let me put a cap on this too. I'm gonna go ahead and close my gas ballast here on my machine. And now we're just pulling through the oil. So we're gonna let this run for a bit. While I'm vacuuming down, we're at about 900 microns right now. I went ahead and fixed this where the wire rubbed up. I just shortened the cord. Connectors under there, and I'm gonna go ahead and put this all back in. It's just kind of bolts to the back. And we're just waiting for the vacuum to drop down. We're making good time, so. All right, I ended up throwing a second hose on there because it was dragging, but we made it below 500 microns. This isn't a low temp, so I'm not too worried about getting any lower than that. So we're gonna go ahead and shut it off and do our decay, and then go ahead and get ready to charge this guy up. Because of the very small charge, I went ahead and pulled the core removal tools off here, put the shraders back in, and the system's still in a vacuum. We're gonna go ahead and hook up my R-290 rig and charge this guy up now, but I'm gonna clean up my work area, vacuum pump, you know, all this stuff first, so get it out of the way. Okay, so I have my smart probes hooked up. I've got my scale zeroed out. We're gonna weigh it in grams because this thing gives you grams and ounces. Tells you 150 grams, so I find that easier. So we're gonna go ahead and use that. We're zeroed out, okay? And we're gonna go ahead and open this ball valve, charge it on the high side to 150 grams. See what we can do here. Looks like this is gonna be a pain in the butt. Oh, there you go, I had it on the wrong one. We're at 110 grams. 120, 130, 140, 150, and we need to overshoot it just a little bit because we got to account for what we're going to lose. So let's see if that overshot it just a little bit. Okay, it didn't. So what we'll do, we're at 150 grams. We're going to go ahead and plug the unit in and start it up and then check the refrigerant. And if you look at my smart probes, we're basically at, sorry, I got a glare there. We've got pressure on both sides. Okay, so that's good. We're gonna go ahead and take this guy off. And then we'll watch the unit operate, and then we might add just a little bit more just to compensate for what we lost. We'll see. We'll see how the unit's operating and what it looks like. So we're ready basically to plug this guy in and test the temperatures. I've plugged it in. We're gonna go ahead and power the unit on. It immediately turns on, but it's gonna pump down right now. So we've got to, I'll get this to where you guys can see it. So it's gonna pump down probably because the temperature controllers need to turn on. But we're just gonna watch it operate and make sure that the box comes down in temp. Okay, so I'm using Measure Quick and the new refrigeration profiles. And yeah, we're pretty dead on as far as the profile setup. We're just waiting for the box to come down to temp. So far it's looking good. I'm not seeing a problem with it. We are gonna run higher than normal superheat because I'm not getting a true evaporator superheat. I'm measuring compressor superheat. Which is temping 51 degrees, but this particular unit, if we walk over here, they insulate the liquid line and the suction line together, so it's expected to have a high compressor superheat. That's gonna happen. So as long as we've got a cold suction line coming back. Another thing to think about too is I'm operating this unit outside of its operating envelope because it should not be operating in a 90-degree ambient like we are right now. So you gotta expect this thing's doing really good for being 90 degrees, and so it's saying my outdoor air temp is 90 degrees right now. So yeah, this is doing really good. So we're just gonna watch it come down in temperature. So I called and spoke to the manufacturer just to get a verification, and they're saying that we should be about 20 to 30 degrees over ambient on our condensing temp, and then they gave me a pressure of approximately 35 to 40 psi for our suction pressure, and they're saying that's at like 35 degrees. So I kind of just went with 40 and kind of figured out my evap TD should be about 20. So with that being said, we were running good and my system actually just pumped down and satisfied right now. All right, so I disconnected power to the unit, so there's no power source. It's unplugged completely. You see the plug right here. Got my fire extinguisher ready, got a wet towel right here, and we've got to go ahead and pinch these guys off and braze them shut. So we're going to use a standard pinch off tool. This is a rounded out head on a set of vice grips. These are made by Yellow Jacket. I'll put a link in the show notes. And what we're going to do is we're going to go ahead and pinch this guy right here. Okay, and then we're going to go ahead and relieve the pressure. Make sure there's no pressure in here. Okay, pressure is relieved, and we're going to go ahead and cut this fitting off, and then we're going to braze it shut. It's the sketchy part. Okay. There you go. Grab some channel locks. Go ahead and pinch that shut. And then we just braze it shut. Easy as that. Very careful. Let that guy cool off. Go ahead and take my wet towel and cool it off. Take the channel locks off, and then we'll do a leak test on it. Okay, gonna put some soap bubbles on it just to make sure we don't have any leaks. I'm gonna soap your little joints right here. I've had them leak on these pinch points too, so you got to be careful. So we'll let the soap bubbles sit on there for a minute. Once we're leak free, then we'll do the other side. Okay, I don't see any bubbles. So what we're gonna do is go ahead and clean off all the soap bubbles, then do the other side, and then we'll hit everything with the electronic leak detector. Okay, I went ahead and pinched off the other side, let the pressure out. See, there's still pressure coming out, so we're gonna go ahead and pinch it a little bit tighter because I think we're still leaking out of there. My vice grips are hot because we're out in the sun. Let's go ahead and get this guy a little bit tighter. There we go. Let's make sure that the pressure stops when we push on this guy. Yep, no more pressure. So we can go ahead and take out this Schrader. And then we'll go ahead and cut this guy off. Okay. Pinch it shut. There's still a little bit of pressure in there. So fix this real quick. There we go. See, so when you take the pinch off tool, it'll still come out, but you can take it off, you know, and I just tighten it down a little bit more. That's all. Okay, light the torch. Make sure we're safe. No fire coming out before we...
kind of feel like I saw a little bit of a flame out there. Like it was pushing some pressure out. Cool it off, do a leak test. Make sure you get your soap bubbles on your other side too. And then we're gonna let it sit. Okay, bubbles have been on there for a minute. I don't see any leaks. So what I did was I turned the system on to make sure that everything was calling. I wanted to make sure that nothing was pumped down. So both the top and the bottom are calling. So we've got pressure in all the lines. We're gonna go ahead and turn off the main power switch. Also that helped because the condenser fan motor was blowing any residual stuff out of there. I zeroed out my leak detector away from the area that we're working. And then now we're gonna bring it up and leak check all of our brace joints. Okay. So we just hit up all of our brace joints here. Alright, so we're looking good, looking 100% leak free, which the bubbles told us that and the pressure test told us that too. But we're just being safe 100%. One more time. Everything looks good. So we can go ahead and give this box back to the customer. All right, so that wasn't too bad. And again, it's nothing to be afraid of. Just follow the proper safety procedures, okay? And only do what you're comfortable doing with working on, okay? Don't let anybody pressure you into working on something that you're not comfortable with, all right? Now, there's a couple, I had mentioned in the beginning of the video that I will have links in the show notes of this video for all the different tools that I used and, you know, all that fancy stuff. Important things to note, evacuation, very important that you properly evacuate these systems, and it's also very important that you double and triple check for leaks, okay? I can't stress enough, I think I stated it 3-4 times in the video, only OEM parts on R-290 systems. Don't ever top off the charge. Don't ever leave a system operating that has leaks, because you don't want to be liable for if something bad was to happen, okay? Because trust me, nobody wants to pay for damages that happen. You know, hopefully nobody gets hurt, but I mean, nobody wants to pay for, manufacturers don't want to pay for damages or anything that happens if there was a fire or something caused by refrigerant leaks. So they're always going to look for someone that maybe did something wrong. Insurance companies are going to get involved and they're going to start pointing fingers. So make sure that you follow all proper refrigeration practices. Pay attention to or look into the training things that I told you guys about. RSCS.org has a great training program on hydrocarbon refrigerants. I'd highly suggest you guys look into that. And then also there's some manufacturers training. I myself have been to the True manufacturing training. They have a regional one that came to my area. And then I've also been to the Delfield manufacturers training. They had a regional one that came to my area. So just look up those resources. Ask the Google, as I always say, and find out where you can learn how to work on R-290 systems. Don't just watch my video and think that you can jump in there and start working on them, okay? My videos are mainly for trained technicians, and it's just to show them, you know, this is the way that I do things, okay? I am no way an expert at doing everything that I do. I am still learning every single day too, and there's always stuff that I can improve on, okay? Other than that, guys, there really wasn't too much crazy. I think I pretty much explained everything in the video, and if you watched till this far into the end, wow, you watched a really long video, but I want to say thank you guys so very much for taking the time to watch these videos. The comments and support I get from you guys are awesome, and I really appreciate it. Any questions, send me an email to hvacrvideos@gmail.com. You can leave a comment on this video. I also do live streams every Monday night at 5 p.m. West Coast time, where I usually answer all the questions from these videos and, you know, just kind of recap some things. So other than that, guys, we'll catch you guys on the next one, okay?